So talking about uncertainty and measurements, and more importantly, how do you do calculations with uncertain numbers, we'll deal with a classic example measuring with a meter stick. For any measuring device, the uncertainty is half of the smallest piece of information you get from that measuring device. For instance, if I'm using a meter stick, and like a typical meter stick, it shows you a marking every 1 millimeter. That's the smallest piece of information you can get, is a measurement down to the level of millimeters. So the uncertainty is half of that, because you're expected to round to the smallest measurement you can see. So if I'm using a typical meter stick, my uncertainty is half of a millimeter. And if I write that in scientific notation, that's going to be 5 times 10 to the minus 4 meters. And every time I take a measurement with a meter stick, it's going to have that amount of uncertainty built into it. So what if I wanted to use a meter stick to measure the perimeter of a rectangle? Typically, when you measure perimeter, you measure the length of a rectangle, you measure the width of a rectangle, and then you do a little bit of math to find the perimeter. You can add the length and the width together and then multiply by 2. So I've got some hypothetical measurements. You can see them right there on the slide, and you can see I've also included the uncertainty in those measurements, which comes from using the meter stick. So now we're going to have to do some math with these numbers, and how do we do that? Well, in this case, when we're adding together, right, we're adding length plus width, we just need to add together what we call the absolute uncertainty, which is the uncertainty when you look at it as a unit, right? In this case, it's 5 times 10 to the minus 4th meters. It's just a number. We call that the absolute uncertainty. So to do that math, I add together the numbers, length plus width, and that gives me 1.08, and I also add together the uncertainties. If I add 5 times 10 to the negative 4th plus 5 times 10 to the negative 4th, that becomes 10 times 10 to the negative 4th, which is the same thing as 1 times 10 to the negative 3. And then I'm going to multiply this whole result by 2. That means I need to multiply the measurement, but also multiply the uncertainty by 2. If we're doing multiplication and stuff like that, and there's no uncertainty involved, right? 2 is just a number, there's no uncertainty there, then it's not going to affect our uncertainty in any special kind of way. You just do the math as you normally would. So the uncertainty in my perimeter measurement is 2.16 meters plus or minus 2 times 10 to the minus 3 meters, which is plus or minus 2 millimeters, which makes sense, right? You're getting a half millimeter of uncertainty in each side measurement, and there's 4 sides. So 0.5 millimeters 4 times adds up to 2 millimeters. But what if we're multiplying or dividing using uncertain numbers? For instance, what if I want to know the area of this rectangle, where I'm just going to be multiplying together length times width? In that case, you can still add together uncertainties, but now you have to add them as a percentage. Anytime you multiply or divide with uncertain numbers, you convert the uncertainty to a percent uncertainty, and you add together the percent uncertainties for the numbers which you are multiplying together. So my first step is to calculate percent uncertainties, and you can do that by taking the uncertainty and dividing by the measurement. So now we see, as I've got the calculations right here for you, that the absolute uncertainty is the same because it's coming from the same measurement device. But the percent uncertainty is different, right? Because my length is really long, the percent uncertainty is fairly small. And because my width is much shorter, the percent uncertainty is going to end up being quite a bit bigger. Then when I do the actual mathematics here, my multiplication is still just multiplying 0.83 times 0.25. You'll see I've expressed my answer using only 2 significant figures, since that's how many significant figures we have in our original numbers. I have meters and meters, so my new unit is going to be meters squared. The area is 0.21 meters squared. And the uncertainty is going to be 0.06% plus 0.2%, which comes out to, obviously, 0.26%. So the uncertainty in the area is 0.21 meters plus or minus 0.25%, roughly. I might want to look at that as an absolute uncertainty rather than a percentage, in which case I just have to convert back. I need to find out what is 0.26% of 0.21 square meters. And in that case, I take my measurement, 0.21 square meters, I multiply it by my percent uncertainty. That's what I've got right here. And that allows me to turn it back into a number with a unit on it. So if I want to look at this area using absolute uncertainty, I would say it's 0.21 meters plus or minus 5.5 times 10 to the minus 4th meters squared.